Why are the biggest companies in the world investing in functional programming? Why now? What's going on? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So just across the board, we see companies investing in functional programming. I'm talking about Facebook. They're doing a lot of stuff, most notably with ML. So they've got this thing called Reason, which is a language with an ML backend, but it's got a JavaScript front end syntax. They've also done React, which they keep talking about as a functional paradigm. They're doing stuff with Flow, so typed JavaScript. Just functional programming all over the place. They do Haskell internally. It's just everywhere. Apple, the biggest company in the world, has moved its main language from Objective-C, which is an object-oriented language, to Swift, which is much more inspired by Haskell and other functional languages. And JavaScript is becoming more and more functional every day. Scala, Clojure, Elixir, Erlang, these languages are just becoming more and more popular. The question is, why now? Why so much investment? What's going on? All right, so hypothesis one is that there have always been functional programmers. Functional programming is an old paradigm. It hasn't, just emerged out of nowhere. It was there very early on. And object-oriented is kind of the newcomer, really. But why now? Well, it could be that just due to sheer numbers, so the number of programmers who are inherently inclined to functional programming is growing, just the absolute number, because the number of developers in general is growing. It's growing exponentially. And so at some point, you're going to hit a critical mass where you're going to start to hear about it. There's a big enough community to have their own conferences, to have their own blogs, their own, they're going to have some effect on the broader world. And so that's what we're seeing. And I think that there's something to that one of the reasons why functional programming is taking off is that functional programmers are numerous enough that they can organize and they can have their own, trade publications and stuff like that. I think there's something a little bit to that. Okay, hypothesis number two, which is really the argument I hear the most, is that we're living in a multi-core world. We can't speed up our processors anymore. And so the only way to really get that speed up is to run in parallel. So you have multiple threads. Whereas before you could just wait 18 months and your single threaded application would get faster. I don't buy this argument. The problem is that we aren't seeing the number of cores increasing on our CPUs. The transistors that Moore's law would predict are moving into the GPUs. And functional programming, the general purpose functional languages don't really, they don't really have an answer to GPUs. I mean, not a great answer. They functional paradigms should work on them, but I think it will take a lot more time before we can use them from a general purpose language in a way that would feel very comfortable and native. So I don't buy that argument. I think it was a valid argument when we were predicting that everyone would have 1,000 cores on their machine very soon. Because it was happening. It was like, oh, I have 1 core, now 2 cores, now 4 cores, now 8 cores. But in the 10 years since that argument came out, we now have 16 cores. It hasn't really increased exponentially like we thought. So no, I don't believe that. Okay, hypothesis number 3 is that we are drowning in complexity. These software, these tech companies are just full of software, full of code, and they just need something else to organize around besides the standard class-based object-oriented programming that they were started with, or maybe even the imperative programming they were started with. I think there's a lot to that. These companies are spending more and more per line of code. They're spending more and more per feature, and they're realizing that if they invest in better abstractions, better technology, that they will, in the long run, gain a lot of advantage. Their lines of code will be cheaper, and their features will be cheaper. And so the question is, why not object-oriented programming? Isn't that full of great examples of design? And I think the answer is that although really object-oriented programmers invented this idea of software design, of how to modify your code so that it's easy to modify, right? So that you can add new features. I think even though they did pioneer that, it's fallen short. It actually is a lot of work to develop your software in that way. And is it working? That's the real question. Is it enough to just move your methods around and come up with smaller methods and things like that? And I think that, I'm just going to say this, the patterns movement for, how to design these reusable things, reusable patterns, right? Not reusable code, but the patterns are reusable. I think it just didn't have the effect that it was supposed to have. The effect it was supposed to have was to teach people these design principles, and for just looking at what actually happened, I think it's made code worse. You have and I'm just speaking in general from what I see of enterprise code bases. You just have a lot of abstract factory proxies and not a lot of stuff happening. And it's unfortunate because I think that there's a lot to the design pattern movement that just doesn't come across. Maybe it's too hard. Maybe it's touching at something that's so abstract people can't really handle it. Okay, whatever happened, I think in the actual real world, it didn't work. All right, so where do you turn to? Well, functional programmers. Functional programmers model in a different way. and they tend toward simpler models, more elegant, mathematically oriented models. Okay, I'm not saying you can't do that in object-oriented programming. I'm just saying people aren't doing it. People like to write factory methods. They like to write singleton classes, right? These are abstractions that take more code than they save, let's say, all right? Whereas functional programmers are the ones thinking deeply about how to make things simpler. Sorry, it's just the truth. It's the truth that I believe, right? It's my truth. When I look around at the world, what's actually happening, it's functional programmers who can see the lines of simplicity and how to design things more elegantly. Not everybody, you know, not everybody, but as a whole, generalizing is functional programmers. And so when Apple needs a new language that's going to define the next 30 years of their code, they turn to functional programming. That's what they did. They said, look, object-oriented programming is not helping. We can't patch this language anymore, and maybe we need a completely different model. So, okay, that's hypothesis number 3. I think there's a lot of merit in that. Hypothesis number 4 is that it's not the number of cores, it's not parallelism in that sense, it's the distributed systems. All the software we write nowadays is distributed system. Whether it's on the web or on mobile, we are writing distributed systems. That's our jobs now. And not that object-oriented people, object-oriented programmers, object-oriented design can't handle that. It's that functional programmers have been thinking about distributed systems and have the right questions to ask that object-oriented design has not asked, has not gone into very much. So functional programmers talk about time, they talk about synchronization, they have models of CRDTs, they talk about associativity, commutativity. These properties are very useful in a distributed world. Just real quick, you have distributed systems when you have multiple computers talking to each other. And that happens in every web app because you have at least a browser and a server. But you have more than that in most cases. You have the database servers, right? You have the APIs you're accessing, so that could be like all the AWS APIs. Those are other computers you're talking to. You have your web server, you have thousands of connected clients at the same time. Your mobile app is not a standalone app. It's talking to a server, has to synchronize with, you know, iCloud or whatever it's talking to. And these things change the game. It's not a step-by-step, do one thing at a time paradigm anymore. It becomes, I just got this message from outer space, from some other computer somewhere, and now I have to deal with it, and I have to make sense of it and like apply it to the state that I've got on my machine in this local process. And what does that look like? And now the user's done this, and I got to send a message somewhere else and try to reconcile all these messages from all these different places. And functional programmers have been thinking about that. That's all. We've been doing that. And so our languages reflect that. Our ideas, our thinking, our way of speaking. Okay, so those are 4 hypotheses. I think that, yes, the number of developers is growing. It's going to make the number of functional programmers grow. that's natural. But these two other problems of having better models that help you simplify the complexity that these big companies are dealing with, especially with large amounts of data. That one, and also the fact that we're all working on distributed systems nowadays, means that we need to be asking questions that don't come up very often when you look at object-oriented design. They come up in functional designs. And so that's why we're seeing companies investing more and more in functional programming. All right, my name is Eric Norman. This has been a thought on functional programming. Please, I'm on LinkedIn. You can get in touch with me. You can connect with me. I'm Eric Normand. Just search Eric Normand Clojure. You'll find me. I'm at Eric Normand on Twitter. Please, if you've got an angry tweet, let me know. Follow me. All those things. Also, you can email me if you have something longer to say at eric@lispcast.com. All right, see you later. Bye.